You asked, you supported, and here it is. Guys, thanks to your help, I bring you the very first Hobbyist PC's PC building tutorial. Welcome my friends, I'm John from Hobbyist PCs, and today I'm going to be doing a live build video for you guys. I'm not gonna do this all in one take. However, I am going to try to get different camera angles to try to show you what it is that I'm doing. So I have a limited selection of cameras on hand. No big deal though, but we'll get through this. Now, of course, let me introduce you to what it is exactly I'm building here today, because this PC is being built for a very specific purpose. However, you could still use this information to build a gaming PC because pretty much all the components are the exact same that you would put in a gaming PC. So what am I using this for? I'm going to be using this as a streaming PC specifically. Most of my load is going to be put on this Ryzen 5 1600 by AMD. And that's going to be used to encode my stream, whereas the AverMedia capture card is probably going to be doing the most important task of actually capturing the gameplay or whatever it is I'm going to be doing on the PC. Keep in mind, I'm not just going to be using this for streaming. I'm going to be using this to do certain captures, maybe benchmarking on certain video games. That's something I could also do as well. So that way, you know, you guys can get a better idea as to what I'm talking about. I can demonstrate things even further in a little more detail. Now, I'm just going to go ahead and do a rundown and explain the different parts that we're going to have on the PC, and then I'm going to get into the kind of tools you're going to need. So let's get started here. Okay, so I guess I'm going to start first with the case. This is a Thermaltake Commander MS-I Snow Edition case. It's nothing fancy, it's a pretty low budget case, which serves the purpose that I need it to. You really don't need anything fancy to run a streaming PC. You're only going to be putting your CPU under load for the most part, and how much underload that's going to be is really going to depend on what you're going to be doing with it. But for the most part, because we're only streaming to a streaming service, it's not going to be that heavily required. So I wouldn't expect it to be generating so much heat that a simple case with a couple of fans in it is going to do the job just fine. And like I mentioned, I do have two case fans in here. They are stock Fractal case fans that I used for my Fractal Meshify C over there. And I'm just going to be repurposing them as case fans in the meantime until I have the budget to upgrade the fans and get them cooling a little better. Now, let's move on to the next part. The most important part probably is the CPU. This is a Ryzen 5 1600. I've had this for a little while. It was used in my sort of like casual rig that we use upstairs, me and my girlfriend, and I've decided to take advantage of the fact, I did post a vlog about it not too long ago, took advantage of the fact that the 1700X was on sale, and I decided to upgrade that machine upstairs with that and repurpose this CPU as an encoder for a streaming PC. And it should do the job great. These Ryzen CPUs are very well known for having good encoder performance, so especially for X264, which makes them very good candidates for that. Now, to kind of match up what's going with it, as far as RAM, so far I've just got an 8GB kit. This is a G.Skill Ripjaw 5s at, I think it was at 2400, yep, 2400 megahertz. This should be plenty for now, and if the need arises where I need to upgrade the RAM some more, I'm gonna go ahead and just buy another 8GB kit and expand on it even more. Since this motherboard right down here has 4 slots, it's not going to be a big deal to slap 2 more 4GB sticks in there to make 16. I'm probably not going to need much more than that for a streaming rig, and for most gaming rigs, 16 is what I would recommend gamers shoot for if they expect to play more modern titles. But don't worry about that with older titles, it's not going to be that big of a deal. Now, moving on to the hard drive, I'm just kind of getting these out of the way so I can get to the motherboard. This is a Crucial MX500, 500GB. That should be plenty of space needed to both run the operating system and all of my programs I'm going to need. That includes OBS Studio as well as all my scene elements and whatnot. Shouldn't be that bad. You know, my web browser, it's going to be a very minimal purpose PC, so I don't need much from it. And for most people, I would say to get started, 500GB is perfect. You can probably actually get away with a 256 just for your operating system. As a matter of fact, I'm still using a 256 in my current rig. But you know, you can just expand with more SSDs if you'd like to add more programs or games or whatever you want. Shouldn't be that big of a deal. Now, the motherboard I'm using, I decided to go with the ASRock AV350 Pro 4, mainly because it was pretty affordable and it had enough USB ports on the back of it that I could manage the stream just fine. This would include my Elgato Stream Deck, which is what you see right here in the front. It would also include a mouse and a keyboard, as well as my webcam, and that's pretty much the bare minimum. I think the last thing I'm going to need if I'm going to upgrade to a analog setup is a USB slot for the USB mixer I'm going to be purchasing down the line. And as far as the last thing I should mention about this motherboard, it is a full size. It's an ATX form factor. So I had to make sure that before I bought this that the case was ATX compatible, and it is. So it will fit a full size ATX board in the case. Make sure you look out for that whenever you buy a case. You don't want to go out buying an ATX motherboard and then buying an M-ATX, which is smaller in terms of form factor. Form factor is what is kind of the technical term for, I guess, the size of the chassis as well as the motherboard. And it's just something that you need to keep in mind whenever you're picking out a case as well as a motherboard. You can go ahead and you can put a smaller motherboard in a bigger case, since the stanchions on the inside of the case are typically uniform. And you don't have to worry about it. They're set to a standard. Of course, like I was saying already, you don't want a bigger motherboard in a smaller case. So just make sure you double check that before you go and make a purchase. And lastly, one other thing I do want to mention too is that it has enough, because it is a full-size ATX board, it's going to have enough PCIe Express sockets for me to use for example, my AverMedia 4K capture card, which I have here. This is probably the most expensive out of everything in the kit here, but it is also going to be the meat and potatoes, essentially, of this rig in general. Now, of course, I want to get to the graphics card. This is an Asus GTX 750 Ti. It's a pretty old card. Nowadays, we're on the 20 series, which is after the 10 series, and it kind of goes back in numerical order. It goes back down to 9. There was an 8 series. Let's not get into that discussion because it wasn't really that mainstream, but it existed. However, this is a 7th, I want to say a 7th gen GTX, 7th gen, or a 7th series, 700. And it's going to be just enough to run what I'm going to be using, a 1440p monitor as my base, essentially. It'd probably be best that I move to 1080p. I'm going to experiment with that. However, it should be good enough to run my operating system as well as OBS. I need it in order to assemble the scenes on OBS Studio, but it'll also be required so that I can even get video signal to the monitor. So we needed to use something. A friend of mine was nice enough to, he's selling this to me. He's letting me use it right now, and of course I'm going to compensate him if it works out, and it should work just fine. So if you're building a streaming rig, this is going to be something that you probably don't have to think about too much. Just keep that in mind if you're building a streaming PC. And lastly, we've got our power supply. This is an EVGA 550 G2 80 plus gold power supply. Probably one of the most important things that I would tell anyone when you're building a PC: don't cheap out on the power supply. Just don't. You will see some fairly inexpensive power supplies, and it'll be tempting to want to buy them. All I have to say is, if you're looking to not have to worry about your PC and keep your components safe for a little while, or at least a long time, I would definitely suggest that you spend a little extra on your power supply, and at the very least get an 80 plus gold. Don't go any lower than that. Maybe go with an 80 plus bronze if you're on a really tight budget, but plan on upgrading that later, especially if you're thinking about getting a higher end graphics card. That's one thing I would tell most people. So please don't cheap out on the power supply. 80 plus gold at the very least, and give yourself at least a little more headroom in terms of wattage. This system's probably not going to consume much more than what I have here. Probably not even close to it. But I'm just giving myself the headroom in case maybe someday I decide I need to upgrade this graphics card, or maybe NVENC improvements get so good that I might want to use NVENC to encode my stream. Let's get on to the next portion of this video where I start talking about the required tools, so that way you can start getting into the build. So as far as the tools that you're going to need, I'm going to go ahead and list them in importance based on what is most essential to complete the job. Then in terms of something that I would recommend but aren't necessary to complete the job. And then lastly, I'm going to list something that's nice to have, but you're probably not really going to need it for the build if everything that you need is there. All right, let's get started and start reading off the tool list. So starting with the most important, of course, we've got in the top left-hand corner, we've got a mouse. Now you're going to need at least, the very least, a mouse in order to navigate the BIOS. However, I would almost say that the keyboard on the bottom is equally as important. In some cases, you might need to actually use a keyboard to navigate the BIOS. So in that case, the keyboard probably is the most essential thing in this entire build. However, I would definitely recommend that you have a mouse as well in case the graphical UI does exist for that particular motherboard. Now, as far as the tools you see in the middle, those are all screwdrivers. The top one is a number 2 Phillips head, and the middle is a number 1. The number 1 is fairly small, so it's really good for the smaller screws you might be dealing with, and the number 2 is perfect for case fans. Now, you don't want to use too small of a screwdriver on a screw, and you also don't want to use too big of a screwdriver on a screw, because both can end up stripping your screws, and then you won't be able to remove them or even tighten them on to whatever it is you're trying to put on the PC. And then lastly, on the bottom, we've got a flathead screwdriver. Now, this is good to have. This almost went into recommended. However, the reason why I put it on essential is because the test I'm going to be demonstrating to you to test your parts out involves using this particular screwdriver. However, it's good to have this during a build because there are some things you might have a hard time removing, like different tabs. Now, it could be great for that. And lastly, on the top right-hand corner is thermal paste. Most builds, especially if you're just going to be using the stock cooler that comes with the CPU, they usually end up pre-applying thermal paste to the build, which almost makes thermal paste not necessary. However, the reason why I say that this is absolutely necessary for a build is in case something goes wrong in the build and you need to potentially have to reapply thermal paste. Now, let's say like you end up not mounting the CPU properly, or maybe there's a faulty part somewhere. Maybe you have to remove the CPU. You're going to need to clean it off the CPU, and then you're going to have to end up using thermal paste again anyway. So this is why I would recommend that if you're going to be doing a build, make sure you make thermal paste something that you should get. As far as what I recommend, that's going to vary with a lot of people. I would definitely suggest that you ask around, but if you want my own personal suggestion, I don't really have any preferences. I kind of just go what people suggest to me, and then I just roll with it. As far as the recommended tools, these are some things that I definitely think you should have nearby because you might end up needing these tools at some point. The first one in the top left-hand corner is a pair of needle nose pliers. They can be very useful sometimes for routing cables through certain slots that you have a hard time reaching if your hands are too big or something like that. Sometimes the needle nose pliers can help you with that. And sometimes you might end up having a hard time. Maybe you drop something in the case and you can't quite get to it. Sometimes needle nose pliers is all you really need to get at it. And on top of that, you might run into certain types of stanchions, for example, that just need a little extra tightening. Well, I don't always recommend that you use pliers to do that. It can be just enough to kind of get the stanchions for the motherboard tightened enough where you don't have to worry about them loosening up or messing up the height. And as far as what you're seeing up top there, that is called a ground strap. Now, the reason why I put it in recommended and not essential is because nowadays you can build a PC without really having to use a ground strap. This is because most components these days have very good shock-resistant components inside of them. Now, I've seen build videos where people have built on a carpet with socks on and a sweater. They did everything possible to try to generate static shock and produce a result that would end up frying components inside of a motherboard or on maybe a graphics card or something like that, and they were unsuccessful. That doesn't mean that it can't happen. It very much can, and I would actually recommend that if you want to be the safest, try to get a grounding strap. If you have any sort of static electricity built up on you, you don't have to worry about that discharging on your particular components. Now, one thing that you can do to try to discharge static from yourself is to simply touch something metal or hold on to something metal while you're handling components. That's another thing you can do. Basically, all the ground strap does is that it attaches to something metal to keep you grounded so that you don't discharge electricity and damage your components. I haven't heard of too many cases where people have done that lately. However, I definitely recommend that if you want to be the absolute safest, that you think about investing in a ground strap. They're fairly inexpensive, and, it's just going to give you some peace of mind. And lastly, of course, we've got a power drill. Power drills, you don't really need them, but they make things a lot faster, especially when you're screwing in case fans. When I show you guys how to put in case fans, you might be glad that you had that. It'll definitely save you from straining your wrist from trying to turn a Phillips head screwdriver too tight, because sometimes screws do become difficult to screw in, and it can happen sometimes, and sometimes a power drill is all you really need to help get the job done. So I definitely would recommend that if you have one lying around, grab one. It'll make the job a little easier for you. And then, of course, we got what I would consider the least essential but nice to have, one of them being an adjustable wrench. I had a situation in the past where I was trying to screw in a CPU cooler, and the stanchions on them were extremely difficult to try to turn and tighten properly. They didn't give me any tools or anything like that. So I ended up having to use an adjustable wrench, a small one at that, to try to turn the stanchions enough so that it would tighten down and actually get the block of the CPU cooler to actually make contact with my CPU service. So that was something that I needed at the time. Now, most builds that I do, you're definitely not going to need it for this build. However, it's something that I think you should think about grabbing if you're going to be buying, for example, a water-cooled CPU, because the way some of those stanchions go in, you might end up running into issues where you can't tighten it down all the way. Next thing you know, your CPU cooler is not making contact. So it's very much a specific case. However, I think it's nice to have. Now, as for this last tool that you're seeing on here, it's more so like a hardware kit. Now, you can buy hardware kits at PC stores, maybe even Best Buy. You can buy them online, that's for sure. Sometimes you might end up dropping a piece of hardware. Maybe the case you bought doesn't come with any extra screws. Having some on hand is just nice. It can bail you out of some ugly situations where you drop something and you can't find it. You know how things magically disappear when they hit the floor. Now, that's just kind of why I would suggest having something like this. You don't need it, right? It's probably the least important thing in this whole kit, but it's something that can be very useful if you find yourself building a lot of PCs, or if you need to build multiple PCs, or maybe you're the type that likes to recycle components or used components. This could be extremely useful for helping you get through that job. And that's all you're really going to need to get this build done. So why don't we go ahead and just dive right in. We're going to start with the very first thing. It's going to involve us actually putting together the motherboard along with the CPU, RAM, and we're actually going to be putting in this SSD, which is M.2. So it's going to go right onto the motherboard, and that's going to be a good opportunity for us to make absolutely sure that our motherboard is working properly, because it'll be detecting the hard drive, the CPU, and the RAM inside of it. We want to make sure all that is working properly. So I'm going to be showing you guys how to put that all together, along with how to test it to make sure that it's working properly. All right, guys, let's go ahead and get into it. Okay, so the first thing we're going to want to do here is we're going to want to go ahead and remove the motherboard from the box. We're going to want to make sure that we have this put into the case as soon as possible. This is going to be something that I'll show you later. Got our SATA cables. You're going to want to hold on to this if you have any external, I should say 2.5-inch SSDs, or if you have any hard drives that you need to attach, you're going to need one of these. You got the instruction manual. I definitely recommend that you use the instruction manual. There's plenty of information inside of there. These are just some various pieces of hardware, probably for the M.2s that go on the motherboard. And then we got the motherboard right here on the bottom. As far as that DVD drive that you saw, I should say that the CD-ROM or DVD-ROM that you saw, this is meant to have different drivers inside of it. Now, you don't necessarily need it. You can get all the drivers you need online, and the motherboard will work just fine out of the box. I always recommend that you download your drivers from the internet, because they will be the most up-to-date. So you can ignore that DVD drive. Okay, so the last thing here you're going to want to do is you want to close up the box. You want to take the motherboard out of the anti-static bag that it's placed in. Do not place the motherboard inside on top of the anti-static bag. I've heard that it can have static on the outside, which I know doesn't really make sense, but just for that sake, you don't need to do that. However, the motherboard will be totally fine on top of the box, and I definitely recommend that you put the motherboard on top of the box. This is how we're going to go ahead and install our RAM, our CPU, and this is how we're going to be testing the motherboard to make sure everything works properly. So let's go ahead and we'll move on to the next step. All right, so the next thing you're going to want to do here is you're going to want to get your CPU, and you're going to want to install the CPU into the socket right here. Now, there's one particular detail about this specific socket, and actually most CPU sockets have the same thing. Of course, whether it's Intel or if it's AMD, you're going to see this little arrow in the corner of the socket. In this case, it's located right over here. Now, that arrow is also located on the CPU. You can probably see a golden arrow right here on the CPU. Now, all you got to do is simply line that up with the arrow. Both arrows are pointing in the same direction, and you're going to want to drop that in. But first, before you drop that in, you're going to want to take this lever, because this is how AMD sockets work. It's called a zero insertion force socket. So it requires no insertion force. You don't have to push down on the CPU to put it in place. Simply, you drop the CPU into that socket with the arrows lining up. It only goes in one way. And that's it. You just drop it. And then you take the lever. Off to the side. Boom. Your Ryzen CPU is now installed. You can double check that. It doesn't come out. It's good to go. And that's all you need to know for installing the CPU. Just keep in mind, like I was saying, in this one, you don't need to push the CPU in. It doesn't lock into place like that. You want to make sure that the lever is up before you place it. And you also want to make sure that the arrows are lined up. Golden arrow here, and there'll be a little arrow symbol pointing in that direction. This might be oriented different on certain systems, or should I say certain motherboards. So make sure that you check for that before you put the CPU in. So next what we're going to want to do is we're going to want to prep the motherboard for thermal paste as well as installing the cooler itself. I'm going to be using the stock cooler that came with the CPU. You can see it right here. And it requires that there are pegs on the side, which are just screws. But in order for us to screw this on, we need to remove these brackets on the side. Now, you might not need to do this for every cooler. For this one in particular, we actually need to. So what we're going to do is we're going to get a Phillips head screwdriver and want to remove these. I recommend using either a number 1 or a number 2, whatever fits best. In this case, I'm going to be using a power drill to remove it. And let's go ahead and just get those removed. That's all it is for there. Now, as for these brackets, you can just take the brackets and the screws, you can put them in the motherboard box and hold on to them later in case you decide to get a different cooler. Okay, so now we're on the thermal paste portion of this video. This is something that I have covered in a different video, demonstrating how to apply thermal paste as well as to remove it. So in the instance of removing thermal paste, I'm not going to cover it in this guide, but I will provide a link in the description so that you guys can check out that video if you need to remove the thermal paste in case you make a mistake. Now, I should mention something real quick before I show you how to apply thermal paste. One thing you should know is that a lot of coolers nowadays typically come with thermal paste already applied to the heatsink. Now, you can see on the bottom here, this is just a totally bare heatsink. Now, that's because I've already used it. Normally, this cooler would come with pre-applied thermal paste. Now, the reason I'm bringing this up because I've met people and I know a ton of people that have unnecessarily applied thermal paste onto the CPU without knowing that the cooler already had thermal paste applied to it. Now, if you're not sure whether or not it has it, if it's a gray surface, more than likely it's got thermal paste on it. Most thermal paste is typically a gray color. However, if it's brass or if it's like a shiny chrome color, then you know that there is not thermal paste on it and then you need to apply some yourself. I am going to be showing you guys how to apply thermal paste, and there are many different ways that you can go about doing it. However, I'm going to be using the method that I've been using for a while, and that's the P method. To be honest with you, there really is no right or wrong way. There are so many different ways that you can apply thermal paste, and there are many debates on the internet about what's correct. All I know is that I've been doing it one way for a long time, and it's never really served me wrong. So what this is, it's called the P method because you're simply putting a dab of thermal paste about the size of a pea, like the vegetable, a pea. And you don't need much more than that, because once you put the heatsink on top of it, it's going to spread that thermal paste out across the surface of the CPU. And then you get pretty good coverage across the entire thing. Some people like to spread it. Some people like to use what's called the rice method, which is you make it about the size of a grain of rice. And I've seen some people do an X. You know, there are all sorts of different ways you can go about it. But the main thing you need to realize about this is that you don't want to put too much on it. You don't want way too much thermal paste on, because then that thermal paste can leak over and possibly get onto components on here. A lot of thermal paste is conductive. I'm not 100% sure if this is or not. There is some ceramic thermal paste. To my recollection, it's not quite as conductive. However, it's best to just stay safe and make sure you apply what you need to it. In this case, we're going to be applying about a pea size, and we're going to go ahead and do that right now. Right to the center. That right there looks like a good amount to me. Came up pretty easy. This is some stuff that a Micro Center employee recommended to me. It wasn't any more expensive than what I was going to buy already. There was much more expensive stuff he could have tried to sell me on. However, he said he's been using it for a long time, and I'm just gonna try it out, see how it works. It's a Arctic MX4 thermal compound. It says 2019 edition. Came in a little pouch, as you can see right here, and let's see how it works out. Okay, so now we're at the part where we need to install the cooler. There's only really two ways you can put it on. You can either put it in with the long screws this way, so go on like this, or you can have it go on like this. However you want to put it on, you want to make sure that you put it on in a fashion that, you know, looks okay in your case or whatever seems to work out. Me, personally, my preference is to make sure that the cable is in a spot where it's going to get to the CPU fan header pretty easily. Now, as far as where the CPU fan header, it's actually located right over here in the corner. And I'm going to go ahead and post a picture of the CPU fan header so that way you guys can see it. And you know, just so you know, you might see fan headers on the motherboard, and you might actually see 4 pins, and then you might get 3-pin fans. When I get to the case fan portion, I'll explain this a little better and why you don't have to worry about it so much, but you just want to keep in mind that these pins only go in one way. They go in with the slot going in on the tab that you see on the fan header. So I like to personally orient it so it's in a spot where I can get to it pretty easily. In this case, I want to make sure that it's oriented this way with the AMD logo pointed towards me. We're going to go ahead and we're going to get that CPU cooler installed, and then we're going to go ahead and move on and start wrapping up everything else that's installed here on the board. Now you probably noticed that I went into a cross pattern on this thing. The reason I did that is because I want to try to ensure even pressure, so I make sure that I do a few turns on each side and just make it gradually work down until it's secure. Eventually you'll get to a point where it stops turning. That's where you want to stop. Don't over tighten it. Tighten it to that point where it just stops turning, and then you're good to go. Alright, this is so you guys can watch me actually install a CPU fan header. Or I should say, the fan. You see that the slots line up with the tab? Pop it in just like that. Not a big deal. Comes out easy, goes in easy. It only goes in one way too, so keep that in mind. Okay, so now we're at the portion where we have to install the RAM onto the motherboard. This is a fairly straightforward and easy thing to do. I'm going to show it to you guys. I'm just going to take this RAM out of the package. And we want to go ahead and we want to refer to a chart that is usually listed in most motherboard guides. And some do it better than others. Now, in this one in particular, I'm going to put it up on the screen. You'll see that each slot has a corresponding sort of label to it. A1, A2, B1, and B2. Please note how it's oriented on the chart, with B2 being on this side that I'm pointing to right now, and A1 being on this far side over here. So you want to make sure you're orienting that correctly first when you look at it. Now, the chart that's located below this is, in my opinion, a little convoluted, but it gets the point across. Basically, since we're installing 2 RAM chips and not 4, we want to make sure that the RAM is installed on both A2 and B2. If we were to put 4 sticks, we would simply just populate all of them without having to worry about it. But if we only had 1 stick for single channel, we'd have to put it in A2. Now, make sure that this is correct, because you could end up with some performance issues if you don't do this correctly, and there's also a possibility that it won't even start or work properly. So, we want to make sure we get those in the correct slots. In this case, A2 and B2. Now, as far as installing RAM, it's really easy to do. All you got to do is you pull back the tabs on each one that you're going to be installing on, and then just go right ahead. Make sure that these only go in one way. They only go in one way. You can see there's a notch right here. You can see that this isn't even. You know, this side's bigger than the other, so if you were to flip it around and put it in the wrong way, it wouldn't fit. In this case, it is going that way, so we're going to go ahead and just pop that right on there. Make sure that it's lined up with the notch in the middle that you can see right on the slot. On both sides, pop it in, good to go. Go ahead, we're going to do the same thing with the other one. Put it on slot A2. And that's it. The clip will usually lock into place when it's all set. Almost didn't put that one in all the way. That would have been a problem. But hey, it's good to go now. So that's all you have to do for RAM. RAM's probably the easiest part of this whole thing. Alright, now we're going to install the M.2 SSD, the Crucial MX500. Really simple install process, but there's a slight trick. Or should I say, there's a slight way that you should keep in mind when installing one of these. First off, you're going to need that one of those little screws that was in the motherboard box. This is meant for the M.2, and as you see on the screen, I'll point out what the different screws are for. There are a few different screws aligned with the M.2 slot, and this is just to accommodate the varying sizes that these might come in. And in this case, this one should be on the longest size, and it should fit no problem. So all we're going to do is pretty easily, we're just going to install the M.2 with the pins facing in, obviously, with making sure that it's going in correctly. Put it in at a slight angle until it goes into place. You'll see that it's raised up now. Now in this case, I'm going to need to get a smaller screwdriver. We're going to take the screw out of the bag. Put it right on the end of the screwdriver. Try to get it on the end. This is the part you got to be really careful with. So you want to do is you want to push down the SSD. We want to get the screw right around there. Take your time with this part because this can be really difficult. As long as you get the screw close, you don't want to cross thread it. Make sure it goes in straight. And once it stops turning, you're good. M.2 is installed. Okay, now that we've gotten past all that, this is the part where we start preparing for the actual testing of components. Now, you typically don't necessarily need to install your hard drive to perform this test. However, because it's an M.2, we can get it done right now, and once we boot it up, we can make sure that the motherboard is reading it okay. That's the whole point of the test, is that we want to make sure that we get it booted up, and we want to see if we can go into the system BIOS in order to, confirm that our parts are being read properly by the motherboard. And that's usually a good indication that everything's okay, at least for now. Now, what we're going to be doing here is we're going to be taking the power supply out of the box, and then we're also going to be plugging our graphics card into its proper slot. And what we're going to do is then connect this monitor. Keep in mind that we're using the graphics card because this particular chip doesn't have integrated graphics in it. So even if you were to plug directly into the HDMI port on the motherboard, it's not going to work. So keep this other thing in mind too. Like, Intel has integrated graphics usually, but if by chance you happen to plug a graphics card into your system and it has integrated graphics, you're not going to be able to use the HDMI in the back of the motherboard as well. This is because the graphics card is going to be read as the primary device that runs video whenever it's installed. So make sure that if you're going to test with integrated graphics, make absolutely sure that you do not have your graphics card plugged in. But in this case, we need to plug the graphics card in, and we're going to try to get power running into everything in the components, and then we're going to go ahead and turn it on. And I'm going to show you guys how to turn it on pretty shortly. But first, let's get everything hooked up here, and then we're going to go ahead and I'm going to show you guys how to turn on the motherboard if you don't have a power switch on the board. Now, I just want to take a second to talk a little bit about the different cables you're going to see on a power supply. Of course, I have to mention a couple of things. First off, this is a fully modular power supply, which means that all of the connectors on the power supply itself need to be plugged in. They can be removed from the power supply, so they all plug into sockets. If it was semi-modular, you would see some sockets on it, but then you would see a couple of big wires coming out of it. And all that means, and in most cases, those semi-modular power supplies, they typically put the motherboard cable, which is the giant 24-pin cable that you see right here. I'll be sure to include a picture up here in the right above me. Then we've also got the CPU pin. It's usually properly labeled sometimes, so keep an eye out for that. Make sure that that what you're plugging into is correct. Usually they only go in one way, so make sure to check the patterns on the pins. This is a CPU cable. That'll usually be plugged in as well. So the CPU and the motherboard on a semi-modular is usually the case, and everything else needs to be plugged in. And then you got ones that are non-modular. Those ones don't have any sort of modularity whatsoever. The cable has everything connected to one cable. They're all tied together and go straight into the power supply. They can't be removed. Now, of course, getting a non-modular power supply means that you're not going to have the flexibility of using only what you need, or perhaps like routing things where you want to. And that's really the only advantage to a modular power supply for the most part. However, a lot of power supplies are moving towards that nowadays, so you might as well get a modular power supply while you're at it. Of course, a quick overview of all the cables. We've got the 24-pin connector that goes on the motherboard. That is, of course, the big connector you see on there on the right-hand side. And then on the top left side near the CPU, you got the CPU connector. This one's 8 pins. The end that you're going to want to plug in is the one that's split off right here. Put them together and you plug them into the socket. Sometimes some motherboards only have 4 pins on them. This one has 8. So we're going to use that end. The other end goes into the power supply. That's the thing you got to keep in mind with fully modular power supplies. You don't want to plug them in the wrong way. Also, you've got a couple of other cables you need to keep in mind. Depending on the graphics card you have, you may need to plug in either 6-pin, 8-pin, or 2 8-pins. Now, the VGA cables tend to split off, allowing you to plug in into a graphics card that has more than its 8 pins. So maybe you'll see like a graphics card that has 2 8-pin connectors on it. Most VGA connectors tend to have a split off, kind of like this one does right here. It's kind of hard to show you, but these are both on the same connection. You can see that this one moves over to this one right here and then goes back down to the power supply. This is for those specific graphics cards that have 2 sockets on them. You want to make sure that you're using that one. In the case where that's all you have, just pick any one of those 2, and that should be totally fine. In this case, we're only going to need a 6-pin, so this one doesn't have a split off on it. And we're just going to use that one, the 6 pins that are on it for that graphics card. And lastly, I want to talk about the SATA connector. This is what you're going to most likely use for a hard drive or a 2.5-inch SSD, not an M.2. M.2s don't require you to have to plug power into them. They receive power through the motherboard, so we don't have to worry about that at all. But this is what you're going to be plugging your hard drives in. In some cases, you might even have to plug in your CPU cooler if you're getting a water-cooled CPU cooler. Some CPU coolers actually end up using SATA connections to provide power to it. So, and I'm talking about the ones that are all-in-one water cooled. Those ones typically might have a SATA connection as well. So you got to keep in mind, this isn't just for hard drives, this is for different peripherals on the board. In this case, we're only going to worry about the VGA, we're going to worry about the CPU, and the motherboard. And of course, we're going to be providing power to it, but first we're going to plug everything in, and then we're going to make sure that we can turn on. So let's get on to that. I want to mention something really quick about the motherboard connector. A lot of the times on most power supplies that are modular, you'll see that the one that actually goes into the power supply is usually split like this. So make sure you won't be able to put that end in at all because it's not split up. But just make sure that you don't try to plug this into the connector on the motherboard because that's going to end in disaster. So I just want to let you guys know about that before I started plugging things in. I'm going to show you in a little more detail how exactly it is that you plug in a graphics card, but for now, all you need to know is that you want to push the tab on the back. You want to go to the slot that's closest to the CPU, and it only goes in one way, so just want to pop that in. I'm going to nudge this over towards the edge over here, so that way I can actually get it over and on. Just goes straight down until it clicks in. Now I want to just make sure that all our peripherals are plugged in before we plug in the power supply. So before you do all this, I just connected everything preemptively. Make absolutely sure that the power supply is not plugged in just yet, or at least make sure that the power switch is off. That's important. Sure, it's not the most glorious looking thing, but it's gonna get the job done. So I'm gonna go ahead and plug in the power, and I'm gonna show you guys how to turn on the motherboard. I should note one other thing too before I go on to that next step. We're gonna be trying to get something called a POST, a power on self-test. This is something that all computers do whenever power goes to them for the first time. They're gonna run a series of tests to make sure that all the basic components are working properly before you can even turn the power on. Now, if you don't get POST and you just get what are called beep codes, if you have a speaker that attaches to your motherboard, which is something that you don't see much too often, a lot of times they're being replaced with little LEDs, but if you're having issues and you can check what are called beep codes, you can figure out if there's something wrong with your system and see why it potentially might not be booting up into the BIOS. But the idea here is that we're just trying to get into the BIOS, and that's what we're going to try to do. So I'm going to get the power on and we'll see if we can get that going. Alright, here we are looking at the motherboard overhead. If you look at the top right hand corner of the motherboard, there is this section of connectors called the front panel connectors. when you look at the front panel, you can see that this motherboard actually has the different switches labeled. It'll have the power button, it'll also have the power LED, as well as the hard drive LED and the reset switch. These are all connectors that would normally be found on your case, and you will have to plug these in at some point if you want to be able to use the power button on them. So what I'm going to be showing you guys how to do is how to use a screwdriver to bridge the two pins between the power button. And that's really all a power button does. It just bridges these two connections, positive and negative, so that it can deliver power to the motherboard. And that's essentially all you're doing, is you're using a metal tool like a screwdriver to bridge those two pins and send a current through it. That's relatively safe to do, as long as, you know, if you really want to be extra safe, just, you know, make sure that your screwdriver has a rubber handle, or just make sure you're not touching metal when you do touch it. And all you got to do is touch the two together. Just bridge the two pins, and then that'll simply turn on the motherboard. So we're gonna go ahead and do that. I'm not gonna put a camera up to it. You're gonna see it from a far away perspective, but I've shown you in the picture which two pins you need to bridge. Just be as careful as you would like, and just make sure you bridge the two. And then once the power comes on, you can release the screwdriver from it. And then when you're ready to turn it off, all you gotta do is turn the power off on the power supply. Just gonna turn on the power switch first, which is located over here. Okay. Now we're gonna go ahead and we're gonna bridge the two pins, which I've already pointed out to you guys. As you can see, it's turned on. Let's see if we can get power to the monitor. There we go. And we're into the BIOS, so we're looking pretty good right now. Just gonna take a look at everything to make sure everything's working properly and being detected. Just gonna go ahead and check processor speed is at 3.2. That's what it's normally rated at. Total memory, 8 gigabytes, right around there. So you can see it's 192 megabytes. That's about how much 8 gigabytes is in megabytes. It's running in dual channel memory right now. That's great. I love that it tells you that. Take a look at the hardware monitor. We can check our temperatures. Right now our CPU temperature is 24. It's going to get a little hot at first. That's normal. That's because the thermal paste needs time to settle in. Once the thermal paste is settled, it's going to run at its normal temperature. Fan speed's working. You can see it's getting a fan speed reading. The fans are spinning right now, so that's a good sign. Just keep in mind, your computer will not start if it doesn't have a CPU fan plugged in. So always make sure that you have that plugged in before you turn this on. The CPU fan has to be plugged in, otherwise you won't even get to the menu. Alright, I've seen everything I really need to see at this point. The fans are turning on the graphics card, fans turning on the CPU. We're getting signal going into the monitor, so that tells me that everything is good to go. So we've passed the test as far as this step is concerned. Now we get to basically shut this all down. All you gotta do is shut this down, hit the power switch, let it all wind down. Take extra precaution when removing the connectors from the motherboard. The motherboard one's going to be pretty difficult to remove, so be patient with that one. Don't worry, you might have to pull kind of hard. It's alright. It's kind of difficult to remove the socket from the motherboard, but just take your time with it. Let's go ahead and get on with that. I should note one thing really quick about removing these. Don't pull by the wires, whatever you do. Try your best to pull from the socket, and I mean like by the connector itself. Try not to pull from the wires, because you could end up pulling the wires out. Same thing goes with this as well. If you have to move these RAM sticks to remove this, do so. Alright guys, the fun part begins here. This is the part we're going to start taking apart the case as much as we can. We don't have to take it completely apart. The idea here is that we want to take out enough so that we don't have a bunch of stuff obstructing us while we work. Now in this case, we're going to be taking off the side panel on the right, and my right, side panel on my left, and then we're going to remove this front section. In pretty much every case, you should be able to remove the front panel every time. However, be careful because sometimes the power button is attached to it, and a lot of times wires are attached to that as well, so you might end up dragging those out or possibly yanking those out. Be very careful. In this case, it's not going to be that big of a deal. I should also mention too that some cases have thumb screws that make it easier to remove the side panels. If you're the type that has to constantly open up their PC for whatever reason, these might be extremely useful for you. So in that case, I'm going to go ahead and just remove these first. Get these out of the way. Put the panel off to the side. Need a screw for the back one. Screwdriver, Phillips head. That blue one was a little too big, so I switched over to the smaller one. Put this off to the side as well. Hopefully don't trip on it. And then lastly, there's this section. This is going to be kind of tough to point out because it's going to be different with every case. This case has little tabs on the inside that allow it to pop into place. Got to be careful with these tabs because some of them sometimes can break. These ones are metal, so they're really sturdy. It's not going to be hard to pull this out, but with a lot of them, sometimes you might need to maybe get the assistance of a flathead screwdriver to try to help you carefully remove the tabs. Because sometimes they're made of plastic and they'll end up breaking, and we don't want that. So in this case, it's not going to be that big of a deal. I'm just going to kind of push the tabs on one side. It's right over here. Yep, there's one up here. Kind of work down right over here. Should be able to just yank that out. Sometimes it helps to kind of work around the case. And in most cases, you can just pull it out. This one, in this one's case, you can just yank it right off. You see, this one's not attached to anything. All the wires are still on the inside. You can definitely see them. All those colorful cables on the inside. Those all go to the front panel. That's that front panel connector I was talking to you guys about, and that's the power button and whatnot. So, want to make absolutely sure that we're careful about those when we pull this panel off. Now, pulling all this stuff off is going to allow us to install case fans, first off. But it's also going to give us plenty of room to work in. So the first thing I want to do is I got two case fans. I got one that's going to be an intake, and one that's going to be an exhaust. Now, that means that the air is going to be coming into the case, through the front, and out through the back. Intake, exhaust. Now, all fans go in both directions. So you have to keep in mind with fans, before we install the case fans, that you want to make sure that the fans are going in the proper direction. So in this case, with an intake fan, we're going to want the air to go that way. And in some fans, they actually label them. There's a couple ways to know how this works. I'll show you two of them. So, first off, you can look on the fan. You can see in the picture that one arrow is telling you the direction of the flow, which is the airflow, and the other one is telling you the direction that the fan is spinning. Now, it's not quite as important to know which direction the fan's spinning, but knowing where the flow is going is probably the most important thing. In this case, on most case fans, all you have to do is look at the side where the brace is for the fan blades itself. That's the side that the air is coming out of. So the side where there isn't a brace, the air is going in that way and flowing in this direction. So you want to think of the air moving towards the brace. Air's coming in on the side with no brace, air's moving out on the side with the brace. So that's one way you can do it. The other way is look on the label, and you could also know the rotation too, because that'll tell you. But sometimes I think that could get confusing. I feel that just knowing what side the brace is on is definitely a better indicator of knowing where you should be putting your fan. So what I'm going to be doing here is I'm going to be installing both of these fans, in this case the intake fan. I'm going to make sure that the brace side is on the inside of the case, and I want to make sure that for the exhaust fan, that the brace side is pointing towards the outside of the case, going that way. Let's go ahead and get those installed. I should mention that in this instance, this fan came with a bag of hardware. A lot of cases come with a bag of hardware, and that's going to be very helpful, especially if you need to mount a fan a special way. In this case, this particular fan requires a long screw in order to get screwed in. So I had to dig out these long screws that would go in to help me mount the fan onto the case. So I'm going to go ahead and do that now. You don't want it to be super tight, but you want it to be snug enough where it won't rattle when it's turned on. Now, like I was saying, as for the back, it's going to be a slightly different deal. Like I was saying, you want the brace of the fan right here to be on the back side like that, so you can see that there's no brace when you look into the case. And you want to line up the holes as best as you can. Then you're going to end up using these screws. Now, I have to mention something if you end up putting brand new fans in your case. A lot of these fans come without any threads whatsoever on the actual holes. Now, there's a couple of things you could do. To get them started, what you can do is you can plop them in straight, just like this. Make sure it's in as straight as you can get it before you go. And then you want to you're going to be creating the threads yourself with the screw. It's a self-threading screw. It's very coarse, but it digs right into the fan. So just keep that in mind. A lot of fans, when you buy them brand new, won't have any threads on the inside of the holes. You have to create them yourself. So keep that in mind when you're mounting new case fans. I personally like to start with the first two before I start mounting. I get like one of each corner. That way it's lined up and it just makes the rest of the job easier. Now, I just want you guys to keep in mind that I'm installing the case fans now because I recall not really having to remove the case fans when I was working in this case. I might have to with this particular motherboard for all I know, but it seems it'll be alright. I recommend it's probably best to hold off on installing the exhaust fans before installing your motherboard and some of the other various components first. That's just because sometimes they can get in the way depending on the case you're working in, so just remember that before you install the exhaust fan. That way it just makes it a little easier, because in this case I might end up having to remove it. We're going to get to this other part. All we're going to be doing here is we're going to be installing the I/O shield, the input-output shield for the motherboard. Now that's this metal thing that I was telling you about earlier. This is basically where the back end of the motherboard is. This side right here. That's usually the back of the case that you usually see on a lot of PCs. Now I want to keep something in mind when it comes to cheaper motherboards or lower end motherboards. With these I/O shields, a lot of the times they just have these awkward tabs on the back of them. And the problem with them is that sometimes they get hung up inside of the ports. I don't know what they were thinking when they designed this, but it's not my favorite design. As a matter of fact, this HDMI one in particular is probably just not in a good spot, so I might end up just either bending it or flat out snapping it off, because it's something that's not that necessary. So when you install your motherboard, make absolutely sure that none of these tabs get hung up inside the ports. Otherwise, you're going to be having a bad time removing your motherboard and having to realign everything. So that way you can actually use stuff. So what we're going to do here is just put on the I/O shield. You want to actually first orient yourself. It's going to be going in like this, so we know that the motherboard I/O shield needs to go on like this. See it on the side, just like that. So that means it's got to go in that way. You go ahead and put that on. The trick to this is to push it in at 4 corners. Just push in each corner until it snaps into place. I'm trying to keep this in front of the camera for you guys. Just push it in with my thumb. There we go. That got it. That's all you gotta do. Just work it in there until it all snaps into place. Okay, so a lot of the times people at this stage will end up installing a power supply first. Now that's personal preference for a lot of people. For me, I personally would prefer
to install the motherboard first. I find that it doesn't really matter all that much what you do first. I would say take it on a case-by-case basis, no pun intended, to decide whether or not to install it first. In this case, we're just going to go ahead and install the motherboard, and as you can see that there are little screw points located all over the board here. These are normally, in some cases, where the motherboard stanchions would go. They look very similar to what you see here, except they would have, you know, a threaded hole inside of it. Now, what is this exactly? This is like a peg, right? Now, this peg right here is actually a locator pin. And what that does is it allows you to make it a little easier to position the motherboard, so that way you don't have to try to line up all the holes. Now, all these holes are going to line up exactly as they would on the motherboard, because it's an industry standard to do it that way. And we want to make sure that we're lining up the I/O portion of the motherboard as well as we can. And like I said, be very careful with these sort of cheaper boards, because the I/O shields are, I hate to say, poorly designed, or they're cheaply designed, I should say. And sometimes the tabs that are used to separate the I/O shield from the motherboard can get stuck into the ports. So you don't want that to happen, because then you might end up having to completely remove the motherboard just to get them out of the way and use them. So what we're going to do here is, normally, like I said, this is where there would normally be stanchions, but because this is raised, we don't need to put stanchions on here. So we can just go ahead and put the motherboard in. Line it up with the I/O as best as you can, and then you want to try to get that locator pin on there. Alright, that took a little bit of effort. As we can see, this is a little smaller than a typical ATX. This might just be an M.ATX, but that's okay because it has everything that I need it to do in terms of length. So all we're going to need to do is we're going to need to install screws at this point, that point, this point, and this point. I'll be sure to show you a picture on the screen so that way you guys can see what it is exactly you're going to be screwing in for this particular case. However, if it was a little longer, as you can see, it would be over here. Now, I do have a criticism with this board's design. This end is kind of flopping off, so when you're plugging in the motherboard socket, in this case, you want to be very careful not to put too much pressure down on here. You want to grab onto the bottom and try to plug that in, but we're not going to worry about that right this moment. We're going to go ahead and just put the screws in. One thing I have to mention is that most cases come with screws that you would use to screw in the motherboard. Just make sure that you double check them first to make sure that they're the proper screws before you screw them in. You don't want to cross thread anything. So if it takes too much effort to screw in, it's probably not the correct screw. You don't want them to be super tight. I'm just giving them one extra turn, quick turn, just to make sure that they're not loose. You also don't want them to be too tight. Don't over tight them, whatever you do. Now's the stage where you're gonna want to install the power supply. It's pretty easy to do. Power supply tends to come with screws most of the time, so whatever screws you got with the power supply, you want to make sure you grab those. If it didn't come with screws, sometimes the case has those screws. So in this case, I'm gonna go ahead and check the bag. As a matter of fact, I think I see them. Yep, I see them right there in the bag. Okay, so I got these 4 screws here. Hopefully you can see them all right. Those normally would fit on a power supply. Pretty easy to screw in. They're universal for the most part. In this case, I want to try to mount my power supply with the fan side pointing down. Now, there's no real right or wrong way to mount a power supply. However, in this case, I generally would recommend that you avoid having the heat from the inside of the case going through the power supply and acting as an exhaust. Because a lot of the times, that ends up leading to increased heat going into the power supply and can end up with you having to deal with loss of efficiency because the power supply is getting too hot and isn't working as well. So in this case, I'm going to make sure the fan's pointed down, like so. You can see that the fan's not on the inside, just like that. And it looks like there's actually a brace here installed on the bottom of the case, so I can actually remove that. I could probably, don't really need it. However, it might be kind of useful. Just to secure the power supply in place. I'm just gonna flip this around. We're just gonna screw those in. All right, now that feels nice and secure.
All right, I had to do just a little bit of cable management here. As you can see, I routed some of these power supply cables around the back and through here. I checked to make sure that the CPU would actually reach over here because there's no way to route it above and into the socket over on the right-hand side. My right-hand side, your left-hand side. And the same thing over here, you know, it should be able to reach this no problem. But the other thing too is I wanted to show you guys the fan headers. I took some pictures of the motherboard to show the location of the fan headers. I wanted to show you how a 3-pin fan connector would fit into a normal fan header because of the slots that are located on it. All you gotta do is line up those slots. They'll work just fine. So don't freak out if you see 4 pins on the header. You'll still be able to plug a 3-pin into it. So I'm gonna go ahead and take care of that right now. So I'm gonna plug the exhaust fan located near the motherboard into chassis fan header 3, which you're seeing on the screen right now. And then I'm gonna plug the intake fan into chassis fan 1. You can put it into any one of those, 1 or 2, it's not gonna matter. However, you know, that's just a preference of mine. I'm just gonna do that anyway. So I'm gonna go ahead and plug these in. Basically what this is gonna do is gonna allow us to run power to the fans so that they work properly. And even to some degree, we can actually control the fan speed and how it'll ramp up or ramp down depending on the temperature of the CPU. That's something you can generally control within the BIOS if you want to, but there are other ways of doing that. But that's just one of the main reasons why you might see me personally recommend that you get a motherboard with a lot of fan headers, so that way you have the extra flexibility. Now, the other thing I want to do now is I want to plug in a 24-pin connector for the motherboard. That's right over here on this side. Go ahead and do that right now. Now let's go ahead, we're going to plug the CPU connectors in. Okay, so after that point, we've got a lot of things plugged in. Now, this is one thing that I'm going to warn you guys about right now. We're going to plug in the USB 3.0 header, and that's this connector right here. Now, I've had an incident in the past where I shorted out a motherboard from bending a pin here and then attempting to fix it. So I advise that you do this part very carefully and very patiently. It's not difficult necessarily to plug in, but it can be a pain depending on the motherboard that you get and the location that's placed in. So what I'm going to do here is I'm going to just route this right through where I want it to go. Right over here. Pull that through. And you want to make sure that the tab is going in and lining up with the socket properly. That went in totally fine. This is so that we can use the USB in the front of the case. And we got one more too that we also need to use for USB. This is a special one. You're not going to find this one too often, but because it only has one connector on the front of the case, it only needs a portion of it. So all I got to do is locate the USB 2.0 section, and I just got to line it up with the particular slots. And then now we're going to move on to the next part. This part's kind of difficult, and I would suggest that anyone who does this part take their time. Now, I mentioned earlier that diagram that I showed you that shows you how to connect all the front panel connectors in there. And what you should do is do your best to follow the directions there when you're plugging in the connectors. You want to make sure that they're not going in backwards. And once you get one in plugged in correctly, you can use that one connector as a reference. And I'm going to kind of do my best to demonstrate that to you. So as you see, you've got these various connectors here, and what they do is they go into the front panel connector. Now, one of the easiest ways that you can tell whether or not something is a positive or negative side is if you look on the back, you'll see that there is one particular spot, one particular pin on the connector that has an arrow on it. That arrow indicates the positive side of the connection. So wherever you see a plus sign, that's positive. The negative is the minus sign is obviously the negative. So use that as a reference. You plug in your first one, one's marked positive, one's marked negative. And if you recall, I'll put that picture up on the screen for you guys so you can take a look at that. And we're gonna make sure that the positive is lined up correctly. And then we're gonna use that as a reference for the rest of them. Man, I never enjoy plugging those in. It's always pretty nerve-wracking because it's such a tiny pin. I do advise that you be as careful as you can when you plug this in, so please don't rush it, and shouldn't be any need to force anything in. It's pretty easy to put these in. Take your time with it. And that should be it for that part. I just got one last connector. This is probably one of the most overrated connectors. What this does, this particular connector, it allows you to use the connection in the front to plug in your headphones or your microphone. And if you need this in particular, maybe you got a particular headset that uses that, then you're going to want to connect this. Personally, a lot of the time, I don't really use it, so I don't connect it. But in this case, for the sake of demonstration, I'm going to go ahead and I'm going to plug it in just to show you how it goes in. Of course, let me show you a picture of the connector itself so you can see it. Alright, now I've just taken care of a little bit of cable management, not much. I'm going to go ahead and kind of like neaten up these cables so they're not all over the place, and I'm going to try to get them tucked away so it's easy to work in here or get in here. Next time it won't be quite as difficult, but this shouldn't take too long. I'm going to go ahead and take care of all that. And then lastly, we're going to go ahead and we're going to put in our graphics card. Alright everyone, here we are at the home stretch. We're almost done. All we got to do now is install both the graphics card and the capture card into the PC. Now obviously you wouldn't need a capture card if this was just a gaming PC, so you can ignore that step. However, they're both installed in very much similar fashions. Now on the right hand side, your left hand side I should say, you'll see that there's a screw and there's a bracket holding down what appears to be these little sort of slots, and we can just go ahead and remove that. Not every case is going to have this. Some cases it's just an open side where you can just mount things to it. It has some screws. In this case it's just one screw, and I could just simply pop out any of these panels that I don't need. They are removable, and they do have replacement ones that I could use to fill in place of the ones I don't need. Now for the graphics card, I'm going to need 2 slots available. What I'm going to do is I'm going to grab my graphics card, and it's going to slot into the same place that we had it last time. Make sure that the pin is down. Make sure that it's lined up with the slots. Should snap right into place. And that should be good to go. And before we put in those screws, we don't need to do it just yet. I want to go ahead, we want to try to open up those slots that we need for the AverMedia card. It's going to go onto one of these slots. We're going to need to find out which slot we're going to want to use. I assume we're probably going to want to use this one. Now, believe it or not, this AverMedia capture card actually goes into the second graphics card slot. So whenever you pick out your motherboard, make absolutely sure that it has 2 graphics card slots. This one's a little slower, but that's okay because we need the graphics card to be working more efficiently than the capture card in this case. So I want to make sure that we remove these little panels that we don't need. Pop right out. If I recall correctly, I'm pretty sure it's the second one that we need to remove. Yep, it's that one. Just pops right out just like that. Some of them, you don't need to worry about popping them out. It's not a big deal. And that's it for that. So next thing we got to do is we want to grab our little bracket right here. Just put it into place. Then we want to go ahead and we want to put our screws in. So it looks like this thing only uses the one brace to screw everything in. So if that's something that might be a concern for you, always make sure that you double check these things with the case before you purchase it. Now the last thing that we need to do with this is that we need to make sure that we get power supplied to it. I want to grab our cable here. Want to route this over. did some quick cable management here because I was having some trouble with it, just because I wanted to make sure the cable was neat, so I wanted to get that out of the way. And of course, that's all set now, so all we gotta do is just put the lid back on and we'll be good to go. Now, as far as building the actual physical PC, that's all there is to it. That's it. We've made it to the end, guys. Now, of course, you guys still have to install Windows or Linux, whatever operating system it is you plan on using. I'm going to have a separate video made that shows you guys how to install Windows and how to install the drivers, basically how to get it set up. And then I'm going to make another video after that, kind of demonstrating how I personally set up Windows for my own personal use. This might be a slightly different case because it's meant to be purposed as a streaming PC. I might do certain things differently than what I might normally do on my own personal PC, but for the most part, a lot of what you will see is going to be stuff that you can use and you can kind of tailor to your own experience. Now, I do want to talk about some common issues you might run into when you're setting up a PC. For one, if you find that the PC is just flat out not turning on whatsoever, nothing's showing up on screen, you're not seeing any power going to it, first, just make absolutely sure that the power supply is plugged in and the power switch is on. Start with that. If you're still not getting it, then I suggest that you go back and you check all of the connections on the motherboard. And if you have to, just remove everything. Just take all the connectors out, reconnect everything again. Just make absolutely sure that everything is plugged in as securely as possible. And if you're still running into issues, then it's very possible that you have a defective part somewhere. There's not much else I could suggest in that situation other than to obtain other parts that you might have either lying around or grab parts from a friend that you can use to test and make sure. But other than that, like, it's very possible that something might be defective inside of that. If you're running into another issue that involves like boot loops, if you don't know what a boot loop is, basically what happens is the computer will constantly cycle on and off. And it'll never go to the BIOS, it'll never go to Windows, it'll just constantly cycle on and off. That's called a boot loop. There are a lot of things behind boot loops, but a lot of the times it's usually the result of either something not working properly on either the motherboard, or maybe you got a faulty RAM stick, or you have some other component that's not working properly, but sometimes just because something wasn't seated properly or something wasn't connected as it was supposed to be. So, like, again, for most issues in a PC build, if everything's working properly, most of them can be fixed by simply just double checking all your connections and making sure they're all working properly. That's it. Just unplug it, plug it back in, and try it all again. And then hopefully that resolves your issues. But as for everything else, it's most likely the result of a defective product somewhere. So do what you have to do to try to narrow it down, and then hopefully it results in you resolving your issue. And that wraps up this tutorial, guys. I appreciate you guys watching the video, and I hope it was helpful. If it was, please be sure to like, share, and comment down below. And also, if you want to stay up to date with any other updates on the channel, please be sure to subscribe and hit the bell icon for notifications. If you want to, you can join up on the Hobbyist PCs community Discord. There will be a link in the description down below, as well as links to my various social media pages. You can also get a link to my Twitch page. I stream twice a week, and of course, I'll be trying to take advantage of this as soon as possible. As far as what to expect in the future, you should expect to possibly see some tutorials on how to set up a streaming PC. I'm going to try to figure out different ways that you can set up streaming PCs, whether you're on a low budget or if you want to go for a full-blown analog setup. There are a lot of different ways to approach it from an audio perspective, but as far as like the video capture portion, there's only really a couple different ways you can do it, and I'll try to cover as much as I can. Just don't expect it to come right away. It's going to come over time. Anyway, guys, thank you so much for watching. I hope you enjoyed the video, and have a pleasant day, everyone. See you in the next video.